Hello, good day viewers. Today we are going to solve a question from Mechanics. Okay, let's see what the question says. It says calculate the force at A and B, that is this support A here and this support B, if the cylindrical container with a radius of 1.5 centimeters hanging on the beam is filled with a liquid of 2000 kg per meters cube density. So how can you solve this? We can try equilibrium of forces by drawing a free body diagram of the beam here and all the forces acting on it. Nothing related to the mass of the beam, the container, the support and the rest are given, so we assume they are negligible. Let's draw a free body diagram of this beam here. What are the forces acting on it? Here, since we have a container with liquid in it, there must be a downward force at this point here, 3.5 centimeters away from point A, let's say C. Here at this point A here and this point B, there must be reactional forces in the direction opposite to the applied force. So since the applied force is downward, the reactional force must be upward. The terminology of the equilibrium of forces is whenever all forces acting on a body are considered, both the acting forces and the reactional forces, the sum of the vertical forces must be equal to 0. Similarly, the summation of all the horizontal forces must be equal to 0. And also, summation of moment at all points must be equal to 0. There are no horizontal forces acting here, so this should be neglected. So coming back to the vertical forces, since summation of vertical forces must be equal to 0, in the vertical direction, we have the upward direction, which is in most cases considered positive, and the downward direction considered negative. So if we look here, we have 3 vertical forces, 2 upward, which are the positive, that is RA and RB, and then for C, which is downward, that is negative. So based on this here, we can sum them up and equate them to 0. Summing up now, RA plus RB minus FC equal to 0. Here, since the moment at all point equals to 0, let's take all the moment acting at this point A here, sum them up and equate them to 0. The moment caused by this RA here at this point A here is 0 because it's acting directly to the point. There is no perpendicular distance. Moment caused by this RB now, since moment is calculated by force times perpendicular distance, the force here is RB and perpendicular distance here is this one from here to here. That is 3.5 centimeters plus 6.5 centimeters, which is 10 centimeters. So MB equal to RB times 10 centimeters, which equal to 10 RB centimeters. Moment caused by this FC now will be negative because it will rotate the beam about a point in the clockwise direction, which is opposing the direction RB will rotate the beam about point A. So moment caused by force C is minus FC times 3.5 centimeters, which equal to minus 3.5 centimeters. Summing the two moments now and equating them to 0, 10 RB centimeters plus open bracket minus 3.5 FC centimeters equal to 0. Here, plus minus is minus, so 10 RP centimeters minus 3.5 centimeters is equal to 0. We can add 3.5 centimeters to both sides of the equation. So 10 RB centimeters minus 3.5 FC centimeters plus 3.5 FC centimeters equal to 3.5 FC centimeters. Here, minus 3.5 FC centimeters plus 3.5 FC centimeters is 0. So 10 RB centimeters equal to 3.5 FC centimeters. Dividing both sides by centimeters now, here centimeters cancel centimeters and here centimeters cancel centimeters. So 10 RB equal to 3.5 FC. Now what is force C? We don't know, but since the mass of the container and the support are negligible, that means we are going to only deal with the liquid. So what is the force caused by the liquid? The force caused by the liquid is actually its weight, and weight is calculated by mass times gravity. Gravity has an approximate value of 9.81 meters per second squared. So weight equal to mass times 9.81 meters per second squared. But what is the mass? We don't know. Though here we are given the density of the liquid to be 2000 kg per meters cube. Formula for finding density of liquid is mass over volume. Equating it to 2000 kg per meters cube now, mass over volume equal to 2000 kg per meters cube. Making m the subject of the formula, multiply both sides by v. So m over v times v equal to 2000 kg per meters cube times v. Here, v cancels v. So what is the volume of the liquid? Since liquid controls the shape of its container, and here it says that the container is filled up, that means the volume of the container must be the volume of the liquid. So what is the volume of the container? The formula for finding the volume of a cylinder is pi r squared h. Pi is 22/7, r is radius, and we have the radius of the cylinder here to be 1.5 centimeters, and we can see that height here is 5 centimeters. But since this is in meters cube, we have to convert this to meters first. 1.5 centimeters to meters is 1.5/100 meters, which is 0.015 meters. 5 centimeters to meters is 5/100 meters, which is 0.05 meters. Substituting here now, v equal to 22/7 times 0.015 meters all squared times 0.05 meters, which equal to 3.5357 times 10 power minus 5 meters cube, which approximately equal to 3.54 times 10 power minus 5. So v equal to 3.54 times 10 power minus 5 meters cube. Substituting here now, mass equal to 2000 kg per meters cube times 3.54 times 10 power minus 5 meters cube. 2000 times 3.54 times 10 power minus 5 is 0.0708. So mass equal to 0.0708 kilogram meters cube per meters cube. Here, meters cube cancels meters cube. So mass equal to 0.0708 kilogram. If we come here and substitute it, weight equal to 0.0708 kilogram times 9.81 meters per second squared. 0.0708 kilogram times 9.81 meters per second squared is 0.694548 kilogram meters per second squared, which approximately equal to 0.7 kilogram meters per second squared. So weight equal to 0.7 kilogram meters per second squared. We know the unit kilogram meters per second squared is equivalent to 1 Newton. So weight equal to 0.7 Newton. Recall, weight here is equal to force C. So force C equal to 0.7 Newton. Substituting here now to this our equation, 10 Rb equal to 3.5 times 0.7 Newton. 3.5 times 0.7 Newton is 2.45 Newton. So 10 Rb equal to 2.45 Newton. Dividing both sides by 10 to make Rb the subject, 10 Rb over 10 equal to 2.45 Newton over 10. Here 10 cancels 10, and here 2.45 over 10 is 0.245 Newton. Now Rb equal to 0.245 Newton. Coming back to this our great first equation, if you substitute Fc equal to 0.7 Newton and Rb equal to 0.245 Newton, Ra plus 0.245 Newton minus 0.7 Newton equal to 0. 0.245 Newton minus 0.7 Newton is minus 0.455 Newton. So Ra minus 0.455 Newton equal to 0. To make Ra the subject of the formula, we add 0.455 to both sides. Now Ra equal to 0.455 Newton. So we found the forces acting at A and B to be reactional forces of 0.45 Newton and 0.245 Newton. Thank you.